Now, life histories contain characteristics of a population like the number of births per reproduction, the age of reproduction, the lifespan, and the probability that the individual will live their entire lifespan. Each population distributes energy among its lifespan, its reproductive events, and caring for its offspring. And related species can have very different life history patterns, like the toads and frogs that you see here. The mouth-brooding toad carries its eggs in its mouth, but the strawberry poison arrow frog, you see the tadpole on its back. The wood frog down there at the bottom, that's the male and the female frog there. So they'll deposit their eggs in the water. So they are similar, but how they care for their offspring is totally different. Whereas the toad up there in figure C, the Suriname toad, carries its eggs on its belly, but the midwife toad carries the eggs on the back. So they're similar life history, but they have different patterns in how they care for their young. Now, R is the rate of natural increase of a population, and K is the carrying capacity of the environment. And some of the populations are going to be R selection, and some are going to be K selection. If it's R selection, it's unstable and predictable environment. And it's going to be density independent factors that control the population growth. The population growth or size is very low relative to carrying capacity. It's the density independent factors that control it. The abiotic factors like storms, natural disasters, okay? That's what controls it. Now, if they are R strategists, they're opportunistic. They have large numbers of offspring, small bodies, they mature early, they don't live very long, and they don't invest much energy, if any at all, in parental care. So we're looking at bacteria, some of the fungus, many of the insects and rodents. If it's K selection, then they're stable, predictable environments, and the population size is going to be controlled by density dependent factors or biotic factors. It tends to be near carrying capacity. The equilibrium species are the K strategists, and these would be those that have small numbers of offspring, their body size is pretty large, they mature later, they live a long time, and they invest a lot of energy in parental care. Looking at this picture here, you've got the dandelions. They're opportunistic. They don't live long. They're small. Many offspring, but they don't care anything at all about them. They don't take care of them. Whereas the bayers that are the equilibrium pattern, the K strategists, they're larger, they care for their offspring, they live a long time, they mature slowly, they don't have a lot of offspring at one time. So the environment is going to be more stable. Now, what happens when a population grows too big? It gets too large for the environment. The white-tailed deer is our example. They are prolific breeders. The females will breed the first year, and once they start breeding, they are going to produce 2 young each year of life. A century ago, there was only 500,000 of them, but today it's over 200 million. The natural predators are absent from many regions. So they have plenty of food available, they stay healthy, they reproduce well, so you got lots and lots of white-tailed deer. but they can start to starve because they eat up all their food. For example, when deer hunting was banned on Long Island, New York, the population outgrew its available food resources, and they started becoming sickly and weak, and the bones became visible through their skin because they weighed so little. They were not healthy at all. And this causes a lot of other problems also. You start seeing them getting in people's yard, eating the plants. You start seeing cars that hit deer, and we also see Lyme disease coming about.